Hello YouTube, welcome back. This is chapter 10, section 8B, Hyperbolas and Foci review. Alright, we're going to take a look at page 674, number 57 right now. Let's see if we can get over there. Come on, wake up. Alright, I think I'm in pen mode. Yes, it is. Okay, so page 674, from the homework page, number 57, says, and I quote, two LORAN stations are positioned 200 miles apart along a straight shore. A ship records a time difference of 0.00038 or 38 hundred-thousandths of a second between the two LORAN signals. Set up an appropriate rectangular coordinate system to determine where the ship would reach the shore if it were to follow the hyperbola of this corresponding time difference. Okay, so let's draw this. All right, let's see if we can make some axes here. Okay, so let's say this is my y-axis. Come on, y-axis. Oh, that's not vertical. Let's try to make it vertical. Is that vertical? And okay, let's say that's vertical. And horizontal for the x-axis. Let's say that's good. Come on, draw it already. Yes, wake up. All right, good. All right, turn that off. So this, let's say this is the origin. I can't draw the origin. Origin. All right, there it is. There's the y-axis. There's the x-axis. Okay, and okay. So now let's say this is LORAN station number 1, and this is LORAN station number 2. Now these are the foci of two hyperbolas, or hyperbolera. I don't know. So let's say the hyperbola looks sort of like this, and like this. Alrighty. All right. Now it says that there's a time difference between two signals. What does that mean? Well, if your ship is, say, somewhere here, let's say, out at sea, and it's receiving a signal from LORAN station number 1, it takes a certain amount of time to get to the ship, right? And then the signal from LORAN station number 2, it takes a certain amount of time to get to the ship. What they do is they measure the time difference, because the time difference, the difference in those two lengths is the constant for the whole hyperbola. Alrighty, so if we measure that, we can figure out a number of things. All right, so let me get rid of these lines. They're going to get in my way. So if the time difference measured was about 0.00038 seconds, and the speed of light is about 186,000 miles per second, then if you multiply your rate times your time, you get the time, the common difference is going to be, what is it going to be? It's 70.68 miles. Just multiply that on the calculator. I don't feel like dragging out the calculator right now. Now that's the common difference between the signal from L1 to S and from L2 to S, right? But isn't it the same here? If you measure the difference from, I don't know what I'm going to call this point, the point A, okay? From the point A to L1 and the point A to L2, if you take that common difference, that's a common difference also because it's on the hyperbola, right? All right. Well, think about it. Isn't all right, so here, let's talk about this. If this is C, the focal length, the distance from the center of the hyperbola to its focus, right? And so is this. This is also C. And this is A. And this is A. Right? Okay. So then what do we have? Don't we have that C plus A is the distance L1 to A? L1 to big A? And C minus A is the distance from big A to L2. So the common difference is from L1 to A minus the difference from A to L2. And isn't that the common difference, D? But remember, how do you subtract? You never do. You add the opposite. So it's C plus A minus C plus A is D. So 2A is D. So if D is 70.68 miles, and that's 2A, guess what? We just figured out that A is half of that, which is 35.34 miles. All right, so based on the common difference being 70 miles and 70.38 miles, that was the equivalent of 2 ways, so we figure out A, right? Okay, good. And so that's the distance, that's what they're asking for, the distance from the center to big A, that's 35.34 miles. So if we actually were to navigate along that hyperbola, we would hit the shoreline at big A, which is little from the center, 35.34 miles from the center, right? Again, don't forget that the distance between the two LORAN stations is 200 miles. That was given too. Alrighty, now let's talk about this. So what does that mean? Well, that means we know C, right? If the distance between two LORAN stations is from L1 to L2 is 200 miles, and that's C plus C, that's two C's, right? Then C is 100 miles. That's what that gave us. So we got D, the common difference, we got A, and we got C. Alrighty. And what else? Well, can we get the equation of the hyperbola itself? That's what's missing. Now, don't confuse this C with the focal length. That's not the C from the focal. That's the speed of light, okay? This C is the focal length. That's what I'm talking about here. So the focal length C is 100 miles. All right, now, remember when we drew hyperbolas by hand, we actually pretended to draw the ellipse, like x squared over a squared instead of minus y squared over b squared equals 1. We pretended it was plus, and we boxed the ellipse and we drew the diagonals, and that made like the asymptotes of the hyperbola and all that kind of stuff. So you can pretend that there's an ellipse in here somewhere, right? So that has a certain length b. All right. So in other words, let's draw a little line here. So pretend that we still have an ellipse where this length here is B, we got this length A on the bottom, and this is C. So now we have A squared plus B squared is C squared because we got a right angle here again. So this is the same setup as if we were drawing an ellipse, but now A squared plus B squared is C squared. Okay, now let's think about this. So that's going to give us B, and we can then write the equation of the hyperbola, right? If we wanted to. So what do we want? Well, H is 0, K is 0, A is known, B is not known, C, the focal length, is known. All right, so what does that mean? That means that A squared, let's see if I can fix this here, A squared plus B squared equals C squared. So to get A, we have A. To get B, I'm going to have 35.34 squared, approximately, plus B squared is, well, didn't we say that C, the focal length, is 100? So 100 miles squared. If you square all that out and you subtract, you get B squared is about, well, these are all approximations, I suppose, because of the initial time difference being an approximation, right? You get 8,751.0844 square miles, which makes B about, these are approximations, right? About 93.547. So we've got C is 100 miles, A is 34.34 miles, B is 93.547 miles, D, the common difference, is 70.368 miles. I think we have this whole trajectory down. I think so. So I think that we can actually write the equation of the hyperbola. Okay, and then the next question is, if the ship is 50 miles away from the middle of the hyperbola, how far out to sea is it? What's the y value there, right? Okay, so now let's write down the equation of the hyperbola, and then we'll plug in x is 50 and solve for y. Alrighty, and so what are we going to do? I'm going to get rid of this sketch because I can't do multiple pages on here. I can do multiple layers. I'm going to start a new sketch, okay, and I'm going to say, all right, so now I get that x squared over a squared, which is 1248.9156, plus y squared over b squared, which we said was 8751.0844, is equal to 1. So now if the ship, if the captain of the ship actually knows that he's 50 miles away from the center of the LORAN system, the x-coordinate horizontally, right? Can we figure out how far out to sea we are so we can pinpoint our location and get home? Let's say we're lost at sea in the middle of a hurricane or something crazy, right? So what are we going to do? We're going to plug in 50 for x and solve for y. Because that was the second part of the question. I didn't read it, but there it is. The first part was how far from the center are you if you hit shore along the hyperbola. That was the little a, which was 35.34 miles, right? So anyway, so b squared, what was b squared here? 8751.0844. All right, so if you solve this, what do? What if we transpose? Oh wait, this is wrong. Sorry, I made a mistake. Is this a good eraser here? No. Is this a good eraser here? No. It's a good eraser. Sorry, I'm trying to get used to this new system here. Okay, that's better. Let's get rid of that. Okay. And let me get back to my pen. Was it this one? Minus. No. What happened now? Whoopsie. Sorry, guys. Okay. Let me get rid of that. I don't want that. Okay. Where was the pen I was using? Was it this one? Was it that one? Sorry, guys. Yeah, that's what it was. Okay. So this is minus because it's a hyperbola. Okay. So if we transpose, we can get that 2500, that's 50 squared, over 1248.9156 minus 1 equals y squared over, so we add the y squared term to on the right side and we subtract the 1 to the left side, 8751.0844. And again, I'll spare you the T84 nonsense right now. So plug that into your calculator, 2500 over 1248.9156 minus 1, and then multiply by the 8751.0844, and you get y squared. When you square root that, y is approximately 93.628 miles. Whoops. 0.628 miles. And that solves the LORAN system problem. Okay, I think that was good. Alright, so thanks for watching. There's a little review on hyperbolas and foci related to hyperbolas and even the LORAN system, long-range navigation using hyperbolic common differences and 2 LORAN stations. Yay! That's what radar is for. Okay, so bye-bye YouTube. Hope that was helpful. Have a nice day.